Hi guys, welcome back to my geometry tutorials. Today I'd like to go over the concept of congruence and what that means when we study geometry. So let's take a look at some slides that I've prepared, and let's look at the definition of congruence for angles. So angles are congruent if and only if they have the same measure. So what's important about congruence is it's a concept that's similar to equality, but it's not the same thing. So let's take a look at example angles ABC and angles DEF. These are both right angles, so they both measure 90 degrees, but they're not actually the same angle, right? Because this one is right here and this one is over here, so they're actually different angles, and we use different letters to kind of show that they are angles. So angle ABC is not actually equal to angle DEF, but we can say that angle ABC is congruent to angle DEF because the measures of the angles are equal. The angles themselves aren't equal, but the measures of them are equal. So we use this symbol like an equal sign with a little squiggly line over it to mean congruence. So now let's go over the concept of a congruent segment. So congruent segments have the same length. So it's very similar to what we did with angles, but we're measuring lengths instead of how big an angle is. So let's take a look at these two segments here, segment AB and CD. If you measure these angles, these lines, they both have the same measure, but they're obviously different lines. So they have the same length, but they're different segments. So we can write down that segment AB is congruent to segment CD. I know this is kind of a new topic for a lot of people, so let's use kind of a real world example of what congruence means. So assuming that flight paths are in a straight line, the flight distance between Boston and Washington, D.C. is 390 miles, and the flight distance between Chicago and Nashville is also 390 miles. So these two flight paths, if you drew them on a map, they're actually congruent because they're both straight lines, and they both measure 390 miles, so they're actually congruent, but they're not equal. Obviously, a plane trip from Chicago to Nashville is not going to be equal. It's not the same thing as a plane trip from Boston to Washington, D.C. So just try to think of a real world kind of situation where you can think of congruence versus equality to kind of make that concept clear. Next, I want to go over a few fundamental congruence theorems. So there are more to come, but let's take a look at the first four. And the first one is all right angles are congruent. So remember, a right angle measures 90 degrees. So all angles that measure 90 degrees are going to be congruent because um, they'll measure the same thing, right? And all straight angles are congruent. Remember, a straight angle is 180 degrees, so all straight angles will measure the same quantity, which is 180 degrees. Angles that are supplementary to the same or congruent angles are congruent, and angles that are complementary to the same or congruent angles are congruent. So this seems a little bit confusing, so I'm going to actually go over a few examples to kind of help you understand, you know, what this actually looks like when we solve problems. But just look at these congruence theorems and just kind of remember them a little bit. So it'll make more sense when we actually solve some problems in just a short while. I want to do a quick recall from what I went over in some earlier slides. Um, Angles are supplementary if their measures sum to 180 degrees. So if two angles make like a straight line, if you add their measures together, you'll always get 180 degrees. And angles are complementary if their measures sum to 90 degrees. A straight angle measures 180 degrees and a right angle measures 90 degrees. So just look over this for a second and let's actually go ahead and do our first real proof. So take a look at this drawing here. We've drawn these segments and these angles, angle 1, angle 2, and angle 3. So we're given that segment AB here is perpendicular to segment AD here, and that segment AC is perpendicular to segment AE. And we want to prove that angle 1 is congruent to angle 3. So let's actually build our proof using facts on the left side of this line and reasons on the right side of this line. So we're going to write down some facts that we kind of derive deductively, and we're going to actually give the reasons why we can actually state these facts. So we always start off with what's given. So we know that AB is perpendicular to AD, that's a given, and that segment AC is perpendicular to AE, that's a given as well. Then we can say that angle BAD here is a right angle. And the reason we know that is because if you watched one of my earlier slides, not today's, but before, we know that perpendicular segments always meet at right angles. So, and since we know that BA is perpendicular to AD, this thing's going to be a right angle. And in a similar way, since segment AC is perpendicular to segment AE, CAE, that angle will be a right angle as well. So remember in our last slide, a right angle measures 90 degrees, and angles are complementary if their measures sum to 90 degrees. So since we know BAD, this angle is a right angle or 90 degrees, and since we have angle 1 and angle 2, if we add these angles together, we get the bigger angle BAD. So if we add the measure of angle 1 with the measure of angle 2, we will get, the sum will be equal to 90 degrees. Likewise, since we know that CAE is a right angle or 90 degrees, if we add the measure of angle 3 with the measure of angle 2, we will get 90 degrees as well. So what we know is that angle 1 is complementary to angle 2, and the angle 3 is complementary to angle 2 as well. And then we can use one of our congruence theorems. Angles that are complementary to the same angle are congruent, so we can see that angles 1 and 3 are both complementary to the same angle, in this case angle 2. So angles 1 and 3 are congruent to each other. So we're done with this proof, and let's go over another proof here. So we have angle 1, which is outside here, angle 4, which is outside here, and then angle 2 and angle 3, which are inside this triangle. And we're given that angle 1 is congruent to angle 4, and we want to prove that angle 2 is congruent to angle 3. So we start off with what we know what's given. Angle 1 is congruent to angle 4. So obviously, since angle 1 is congruent to angle 4, the measure of angle 1 is equal to the measure of angle 4. We can also see from the figure that if we add angle 1 and angle 2 together, we get the straight line. And if we add angle 3 with angle 4, these two angles together make this straight line. So this is actually going to be a straight angle or 180 degrees. So if we actually add the measure of angle 3 with the measure of angle 4, we would get 180 degrees. And if we added the measure of angle 1 with the measure of angle 2, we would get 180 degrees as well. So we can write down that angle 2 is supplementary to angle 1, and that angle 3 is supplementary to angle 4 because they sum to 180 degrees. And we know that um, we know from this theorem the angles that are supplementary to the same or congruent angles are congruent. So since we know that 1 and 4 are congruent, and since angle 2 is supplementary to 1 and angle 3 is supplementary to angle 4, angles 2 and 3 will be congruent. So angles supplementary to congruent angles are congruent. So I hope you enjoyed this geometry tutorial. I will make more, and this is kind of like a short introduction to problem solving and proofs in geometry, which you'll do a lot more, but I hope this makes it a little bit easier to understand. So I look forward to seeing you for my next tutorials, and everyone have a great night. Bye.